Foundations of amateur radio. If you have the need to switch something on and off, a likely first candidate is to get a switch from the local hardware store. The principle is pretty straightforward. You put the switch into the power supply lead, and by pushing it on, the two halves of the switch make contact with each other, completing a circuit, and the thing you're switching turns on. It's a lot like having two bits of bare wire that you can touch the ends together. What if you want to remove the human touch from the equation? That is, switch something without having to actually push a switch. A potential candidate for this is a relay. In essence, it's exactly the same as a manual switch, except the pushing is done by an electromagnet. The way it works is that you send a current through a coil that is wound around a metal core, which results in a magnetic force. This force is used to push or pull the switch open or closed. Now, both a manual switch and a relay have moving parts. That means that there is a limit on how fast you can switch something on and off. You can probably push a manual switch several times a second, let's say 10. So the switching speed is called 10 Hz. A relay can likely get you switching around 100 times per second, or 100 Hz. But if you want to switch something at a much higher speed, say at 1000 Hz or more, some other form of switching comes into play. At its simplest, a transistor is like a relay, without any moving parts. There's no actual switch, no coil, no electromagnet, none of that. Without going into the physics of how this all works, let's look at an analogy. Imagine a water pipe with a valve on it. You can open or close the valve and water flows or not. In a transistor, the same principle applies. There are three legs. Two of them act as the water pipe. The third one acts as the valve. You open or close the valve by putting a current onto the valve, or base leg, and a current flows between the other two, the collector leg and the emitter leg. Now, so far I've just told you that you can open or close a transistor with a current. But it's actually more nifty than that. You don't need to have it all on or all off. In our water pipe, you can set the valve to any setting and control how much water flows. In a transistor, you can do the same by changing how much current you put onto the switching or base leg. You might have heard a description that says that a transistor is both a switch and an amplifier. If you haven't, don't fret, I'll explain. Let's go back to water for a moment. Imagine a huge water pipe connected to a dam. Lots of water all pushing into our water pipe. The valve we have can be controlled by you blowing water through a straw into the valve. The more water you blow into the valve, the more water flows out of the dam through the pipe. If you blow hard into the straw, the result is a wide open valve and lots of water from the dam. If you blow softly, less water. In essence, your little water flow from your straw is being amplified by the dam. A transistor works just like that. As I said, you don't have to use a transistor just to switch something completely on or completely off. If you vary the current into the base, you can vary the amount of flow between the collector leg and the emitter leg. The current you use to control the flow is tiny, so you can use a really weak signal to control the thing. In essence, that's how a transistor radio works. The small signal that we use to control the flow is the tiny one coming from an antenna. The dam is the battery and the speaker is connected to the output. So a small electrical current coming from the antenna controls the transistor, which in turn controls the amount of current coming from the battery onto the speaker. A hearing aid also works in the same way. A small current coming from a microphone controls the transistor, which in turn controls the amount of output from the battery to a speaker. The reason I mention transistor radios and hearing aids is because that's how the invention of a transistor in 1947 was popularized, since it was seen as a nifty gadget in the days of valves with little application in the real world. Since then, we've combined billions of transistors into chips that we use daily to see what time it is, what the weather is like, and to write emails, control rockets, save lives, and do all the things we take for granted in our electronic world. The transistor is an example of a nifty idea that you may think of as being a difficult concept, but in reality it's not that hard. Don't get me wrong, there are many different types of transistors, each with different characteristics and limitations, The physics don't work like water, but knowing the basics of how it works will be sufficient to get you on your way. I'm Onno, Victor Kilo 6 Foxtrot Lima Alpha Bravo.